In this video, I'm going to show how RedPoint data management can be used to carry out some of the core operations of ETL, extraction, transformation, and loading, inside a Hadoop cluster. And this is all done using the regular data management, sorting, and joining tools, along with this one extra thing called the parallel section. Now, the parallel section means that everything you put inside this box happens in parallel on Hadoop. The data all comes in on this top bar and all goes out on this bottom bar. So if I want to sort some data, first of all I need to find it. I'll go browse and find some data that I've got stored in HDFS. This is 10 gigabytes of records, about 100 million records. When I analyze this file, it'll show me the content. There's basically a line of random text, 100 bytes of random text, followed by a random number, and I want to sort this into order. Now, one thing that is notable about our parallel section is that on any input, you can say, go to the Parallel tab and say, I would like to partition this input by a particular field. In this case, I'll choose that random number field. And what this does is it causes data management to do a distributed sort on that entire data file or input data files and produce grouped records that go into each task. So once the tasks on the inside are launched, they'll be presented with groups of already sorted and partitioned data. And because of that, we're really pretty much done. It's already sorted. And so all we need to do is send the data somewhere. I'll send it to a DLD output, and I'll put it in a temporary folder. What this tells data management to do is to create multiple file parts, very similar to how MapReduce would do it, and to put those file parts in this folder. Because the data is already grouped and sorted, that's it. That's my parallel sort. I just run it. And data management is going to do two things. It's going to carry out this distributed partitioning on the cluster. And if we look at our management console, you'll see those partition projects running. And once they're done, it's going to execute the transforms, which really aren't much more than merging that partition data and writing it to the output file parts. Now, for comparison, we've also done this kind of work in MapReduce and in Pig. Our running times are very, very similar to hand-tuned MapReduce code, hand-tuned Pig code. The difference is that this takes about 30 seconds to put together, and there's no coding, there's no scripting. Alright, I paused the video to skip over the entire running of the project. As you can see, it finished in 1 minute and 40 seconds. That sorted 100 million records, 10 gigabytes of data, and wrote it to all of these output file parts. I could turn around and read them all back in, and you would see that they were all sorted. This is also very easy to do. I just go get my data input, browse to my temp folder, change this to a wildcard read, and add a validate sort, and validate that it is indeed ordered on that column that I expected. And this is now, scanning through 100 million records and verifying that those are sorted. This would produce an error if they weren't. However, I could do this same thing in the parallel section itself. I can validate that sort order in parallel by going and finding those same files, wildcarding the input, telling it to do file splitting now, putting in my validate, and then I don't really need to see the output. I'll just send it to a filter so it dead ends and gets thrown away. Now all the checking will be done in parallel. And there's my transforms running and validating the order of that file. All done? So let's try another one. Very similar to this parallel sorting, we will do parallel join. I have 3 files that have already been loaded into HDFS. They are 10 gigabytes, 1 gigabyte, and 10 gigabyte. Once again, if I analyze them, you'll see that they are a random line of text followed by a random number. I have 3 of them now, so I'll go get all 3, analyze each one. But then I need to tell data management that I would like them to be partitioned by my join key, the R. Because data management is going to present this pre-ordered, pre-grouped data to the interior of the parallel section. And that's where I'll actually do my joins. So we'll join the first 2 together, cascade that into the second join. We'll join by R, a random number, and I'm going to rename these lines so that I get all 3 of them out. Now, because I know that these files contain random numbers and they don't have all the keys in common, I'm going to get a fairly small output out. So when I run this, data management is first going to partition all the inputs in parallel. So it'll do that distributed sort. This is very similar to MapReduce doing its mapping phase. And once it gets done with the distributed sort and starts the transforms, we'll see those appear in our management console as well. I can attach to one of these and actually watch what it's doing on the interior of that parallel section. It's created a set of tasks. Each of them looks very similar to the original transform, except now each one of them is working on a slice of the data instead of the entire thing. Each of these transforms has a group of records grouped by that join key range, already sorted, and they're just doing the join work now. And once this finishes, it's going to take the consolidated output from all of those tasks, and we're going to output it outside of the parallel section back into our data management server into a viewer so we can look at it. And there's our results.